Again at functions, everyone. Hello, this is the Bridge for Math. Functional notation. So math is a language, as we know. We need to come up with ways to write it out and communicate what we're talking about. So again, the good old F word function, functional notation. The letter F is used to say function. Key point here, math books and other people try to trick you. You can use any letter or symbol that you want to represent a function. But for common usage, let's just use F. Notice I have parentheses here. Parentheses usually indicate where something's going to be plugged in. So it's an input location. So here, X in Bad Blue Blue is your input equals Y, which is your output, as we said in our earlier video on the concept of functions. So right now, if you look at it again, remind you about the machine. A function represents a machine, where X goes into this machine, the black box function, you get out a Y. How do we say it in words? We said math is a language. How would we say this in words? In words, the long way would be the function F of input X is equal to Y. Now, almost no math teacher is going to say it that way because they want to go too fast. The quick way, the shortcut is F of X equals Y. I want to stop here because a lot of people, even though you see this, you're not logging this in. Please listen. F of X and Y are equivalent ways to say the same thing. So let's talk about this. We'll start with an easy example, a linear function. Linear function. Have any of you seen y equals mx plus b? Yeah, it's slope-intercept form. Did you ever know that that was a function? Essentially, y and f of x are equivalent. So instead of putting a y there, you put f of x. What does your function do when you put in a certain x? Well, you multiply it by your slope and you add your y-intercept. So let's look at an example with numbers. Thank goodness, let's get to numbers. Enough of these letters. So what if I said solve a function f of x is equal to 5x minus 4? So let's look at what is the machine doing? The machine's taking what you give it, multiplies it by 5, and then subtracts 4, and that's what your output's going to be. So would this be a cool banking machine? Absolutely, with big inputs it would be. So let's try an input of x equals 2. So x is your input, part of your domain. How can you solve this question? All you do is you plug it in wherever you see an x in the function equation. So notice the 5, which was the slope, stays there. Notice the minus 4 stays there. What's the only thing that changes? The x goes from x and changes into a 2. You substitute a 2 in there. So now you have 5 times 2 minus 4 gives you 6. So with an input of x equals 2, you get an output of y equals 6. Let's try it for 0. Do any of you know what it represents geometrically when x equals 0? Ah, yes, it's your y-intercept. So let's try it. Plug in 0 for whenever you see an x. 5 times 0 is 0, minus 4 is just a negative 4. One last with a trickier negative number. X equals a negative 2. Put in negative 2. Notice I have parentheses here again when I substitute that input value. 5 times negative 2 is negative 10. The negative 10 minus 4 is negative 14. So this is a quick way of seeing how inputs lead to outputs. Now I'm going to show you a question that's often on exams that most people miss actually. But if you think about it carefully, you'll crush it and dominate. The thinking example is, do the following ordered pairs represent a function? So anytime you see a question, you got to break it down. Well, what's an ordered pair? Do you remember ordered pairs are x comma y? X comes before y, hence it's ordered, it's in a certain order. Now if we look back at the question we did, do you remember when we had x equals 2, what was our output? It was 6. So actually, when you look at a function, you can actually create a whole bunch of ordered pairs, x's and y's. And it's actually a great way to organize them. So you have x is your input, your domain again, y is your output and your range. So let's look at this. If you look at all these numbers, and it starts to get a little intense because you have what brackets or braces, you have parentheses, you have all these commas, but these are each different ordered pairs. And ordered pairs where the first thing represents x, and the second one represents your y. But let's keep going. Make sure you remember, X is your input, Y is your output. What is the only thing we know really intrinsically about functions? Well, we know we're supposed to get a unique output. When I put something in, I better know what's coming out. If I'm putting in popcorn in the microwave, I better get popped popcorn out. You need to know what goes in and what goes out. So, to answer this question, if I have all these x's in my domain and they give me y's that make sense, then we're good. It's a function. But what happens, and I'll give you a hint, do any of these inputs happen more than once? The answer is yes. X equals 2. So focus in on this ordered pair and this ordered pair. In this one, you put in a 2 and you get out a 5. Not bad if you're banking there. But in this one, you put in the same 2, but you get out a negative 3. You're losing money. That's not functioning. It's giving you a different output. When you can't rely on what you're going to get out, it's not working. Think about a calculator. If you put square root 16, you get out a 4. You're like, yes, it works. What happens if you do it again and it comes out a negative 3? You know it's not working. It's not functioning. So that's your memory trick. So in this case, when you put in x equals 2, you get more than one output. So the answer to this question, no. These ordered pairs do not represent a function. And I hope that helps you. This is the Bridge for Math. My best to you is you conquer more function questions.